Okay, let's look into Loftin-White amplifiers a little bit more. And I have received a fantastic comment for the video by Lou, and he said, he mentions here a very valid comment that when you look at the circuit being direct coupled, if the input tube has a problem with bias, output tube will suffer by it being turned on too hard and potentially burn out. Secondly, the cathode resistor on the output stage has to be quite large, and more resistance in the output stage is not good for power delivery, dynamics, and bass. So let's have a look at these issues, and I'll explain what these are and what can be done about them. Wait a second, is Yoda showing the middle finger there? Crazy, I never noticed that. Anyway, let's go back to Loftin-White. And here I just drawn a little schematics for like a simplest direct coupled circuit. So what Lou was saying, the problem with arises from the fact that the power tube receives its bias from the input tube. So it means that the input tube has to be at the correct voltage before the power tube turns on, so to keep its bias. If the input tube is turned on after the power tube, then you can have a catastrophic failure because the bias is not being right. Also, if the amplifier is already working, if something happens to the input tube, then the bias will go away. The bias stability will go out and the power tube can run away. So now let's see what can you do about that, and I will show an example how stable these amplifiers are, because my point here is to introduce a different solution to you. But of course, if the solution has stability issues, it's not a real solution. So now let's see how can we delve into this circuitry by having stability as well. So the key issue, one of the issues with the Loftin-White, one more thing to add, is that the voltages, the high voltage is much higher compared to a capacitor coupled circuit where you have a capacitor here, because in a coupled circuit you have a small resistor biasing your power tube, or maybe you are using fixed bias. Anyway, your cathode is close to ground potential. However, here you have to elevate the cathode to a potential that equals the plate voltage of your input tube plus the bias voltage. So it will be sitting quite a bit higher than ground. And compared to a coupled version, you can easily add about 150 volts in addition to your B+. So instead of, let's say, a 250 volts bias supply, we are looking at a 400 volts bias range. So that increases the demands on the power supply. And also, if there's a failure, it will be even more spectacular, because it will be 400 volts that's going to make your tube run away instead of 250 volts. So let's see what was my solution for the issue and what you can do to make your Loftin-White amp stable. And I can tell you that I have built along the years 2 Loftin-White amps for myself, and I have friends, and I built 3 more Loftin-Whites, and all 5 have been of exemplary stability, and so stable that in my double DC Darling amp, which I built about 20 years ago, it's running the same set of input tubes. The power tubes all work still. I never even had to rebias it, and I put in maybe several thousand on-off switching into it, and probably like 10,000 plus hours, and it's been rock solid, rock stable. Even if we had like power going out, or power surge when it was working. However, let's see what creates stability here. So one thing which is really critical is that your high voltage has to be turned on after the heaters of your input and power stage are already on. So it means that when the heating is on for input tube and heating is on for power tube, so the tubes are warm enough to conduct at their full potential, and when they receive the high voltage, they bias up properly. If you have that problem that your one of the tube biases up before the other, for example, if your power tube takes too long to bias up, then it means that if your input tube is already hot when it receives the high voltage, then there is no current draw from your power tube. So it means that the voltage it will receive will be super high for the input tube, and it can damage, it can burn out your input tube. So this is what Lou was referring to. And if you let's see, so let's just stick with that scenario now. So eventually tubes require, most tubes, between 5-10 seconds to heat up. So if you have a rectifier that takes longer to warm up than 15 seconds, you will be fine and you will have no problem with the turn on voltage. But if you want to use a solid state diode instead of a vacuum tube rectification, you will have serious issues, because then you will have an instant 400 volts tugging on your input tube, and if your input tube probably cannot take that high voltage, so it will just burn out. But if you use a vacuum tube rectification, especially something that is a slower turn on, like a 5AR4 or damper tubes, like I've been using damper tubes and they take like 45 seconds to turn on, so they are super gentle on your circuit. I can really recommend it for Loftin-White supplies. Or 5AR4 also has a slow turn on, so when you use these you will have no problem with the circuit. Another consideration is you need an input tube that is super stable. So if you have a very stable, very dependable input tube, then it will create a constant dependable bias for your power tube, and it will not be an issue. So for my darling amp, I've been using the 6J4, which has an exemplary stability. It's a triode. The military version is this one, 8532, and the British military, this is the most premium version, the CV5311. So this tube is so rugged that if your amp is on and you drop it from 6 feet high, and of course you have made sure that your tube is held in place and you don't drop it on the sleeve of your tube, it can survive a 6-foot fall, and there will be no impact on the operation of the tube. So it's like this tube was designed to survive in rockets basically, and military applications. But the most important part is it sounds amazingly good. It's the best of all 6J4 varieties by a long shot. And also it's so extremely quiet that when you run it with AC filaments, it's going to be quieter than most tubes run on DC filaments. So this 6J4 family is an exceptional tube, and I really can warmly recommend it in Loftin-White circuits as a driver tube. So if you are worried about bias stability, use any of these and your worries are of the past. And there was the second consideration, and that second consideration is this large cathode resistor. Before we go on, I want to share something more about you, is that because of this large cathode resistor, if there's a bias failure at this point, then your power tube cannot run away, because the cathode resistor will prevent excessive current from running through this tube. and eventually it will give you a chance to shut down your amp before some damage happens to your output transformer or something else. Anyway, I never seen this done or happen because none of the Loftin-White amps that have been around me had any problems like that, but this large resistor really helps with stability as well. However, Lou commented that because of this resistor, because it has to be around like 4K or something like that to provide that extra 150 volts of cathode voltage there, it is of this big value, and that's not good for power delivery. Yes, that's a correct assumption and correct thing. And what you have to do to that is bypass it with a capacitor. So I would say for Loftin-White circuits, cathode bypass capacitor is mandatory for base response. However, when you do that, you can be and you will be amazed that actually these amps can deliver quite a bit of heft with them. Of course, if you are looking for such treat as #1 prize in a car stereo show, no, you won't get that. Your 10 kilowatt solid state amp will easily deliver more juice, more power. But if you just want to listen, for example, to a cello reproduction, then your Loftin-White amp will probably give a much more faithful cello reproduction than other amps who are geared for really high bass power delivery. So let's see. So eventually for bass response, I would say that the Loftin-White amps, these free power amps, have a different bass reproduction compared to high power amps, and that difference in bass reproduction and perception is the same difference as when you go to a jazz concert, and there are some jazz concerts where they have unamplified double bass, and that sound, that if you like that kind of double bass, then this Loftin-White circuitry will be for you. But if you do not like unamplified double bass because you cannot hear it, and you prefer amplified double bass, so when the double bass player has an amp and you hear the amplified sound of it, then this will not work for you. Then you will need a solid state amp, or you can use also a tube amplifier in a push-pull configuration, or just a single-ended but with a higher power output. So I would say that in my experience, the Loftin-White bass can go easily down. So for my Darling amp, which was a double DC Darling, about 1.5 watts output power, I was using it with 95 dB efficiency void pipes, and with them it could easily, and that was a single driver speaker, so an 8-inch driver was reproducing everything, and with that it worked down to the 30s, to the mid 30s. It gave a really good reproduction, but not, definitively not down to the 20s. Actually, I will make later on this year some more tests. I will get out my little Darling amp and hook them up to the Altex to see if they can go lower than that, because with the Fostex void pipe situation, the void pipe was a limiting factor, so even if the amp could have gone lower than that, the speaker doesn't let it go. So I will try it out how it works with my Altex, but I do not think it will go as deep as my push-pull ampexes can go. So anyway, I hope this is a little bit of helpful for everyone. If when you design a Loftin-White amp with stability in mind, they are beyond stable. I have never seen, or I would say, I wouldn't say I never seen any amp that's as stable as them, but it's been, I mean, they've been all 5 Loftin-Whites that we have built here, been exemplarily stable. None ever needed even a tube change over the past 20 years, and I cannot say this of any, or I would say of most manufactured amplifiers that you can buy off the shelf, that they last 20 years. Even if you have like any tube amp, you have to rebias after a couple of years. That at least you have to do that and then change tubes. But with these guys, I had none of those happening. So anyway, thank you for joining in, and when you build and design your Loftin-White amp, pay extra caution so that your high voltage turns on after your tubes heaters are already heated up. Bypass your cathode here as well to improve the base response, and you will, and also use an input tube that is super stable, and avoid solid state rectification, because that turns on really hard, and it doesn't let your system to bias up properly. If you have a slow turn on tube rectification, as it turns on slowly, it allows the system to bias up gently without pressure. Thank you. Please like and subscribe. Bye bye.